Now, something comes up in calculus. Suppose I want to rationalize this denominator, and you're going to have to do that in your next class. You multiply by its two terms, conjugate, the same exact thing, except you change that from a minus to a plus, or a plus to a minus. Whatever I multiply the bottom with, I multiply the top with. Why is that? A ratio of 1. Now, for the denominator, I want to make sure that I rationalize. When you multiply this, you're going to get the first squared minus the second squared. And the denominator is going to be x plus h minus x minus h. The denominator will be x plus h minus x plus h. So my denominator will be simply 2h. As for the top, I FOIL those. I'll get the first squared plus twice the product of those plus the last squared. I'll get x plus h plus twice. If I multiply those, isn't that x squared minus h squared? And the only reason I'm multiplying those because that's how they write it in the back of your book. X plus x is 2x. H plus h is 2h. Oops, I'm sorry. Those cancel out. Plus twice the square root of x squared minus h squared. And do you notice I could factor a 2 out of the top? And that's x plus the square root of x squared minus h squared over h. Now, even though it's tempting, I cannot move that or that out of the radical because those are subtracted, not multiplied. If they were multiplied, I would have been able to do that. They're not multiplied, so be careful with that. Something else comes up in your next class is radical equations. When you see an equation in math, to solve it, you isolate it by itself. This is already isolated by itself. How do you get rid of a cube root? You cube. 3t plus 1 equal negative 2 to the third is negative 8. Subtract 1 and divide by 3. And how do you solve? I'm making a problem like 66. I'm changing something in it. You isolate the radical by itself. You square both sides to get rid of a square root. And that will be 12 minus x equal x squared, or x squared plus x minus 12. And by now we know that that's a negative 4 and a 3. But since I started the problem with an even index radical, domain applies. I need to check. The checking is simple. You could do it visually. You put a negative 4 there and a negative 4 there. Minus a negative 4 is positive 4. Plus 12, that is 16, that's 4. Minus a negative 4 plus 4 equaling 0, that's not true. So that doesn't work. You try the 3. You put a 3 there and a 3 there. 12 minus 3 is 9. Square root of 9 is 3. Minus 3, that is a 0, that checks. So the answer here is only 3. Negative 4 doesn't work. Whenever you start the problem with an even index radical, a log, or a fraction in which the denominator could equal 0, you need to check your answer. Now, this we did up there. But this, if you see a raised to the L over n, you have two options. It seems this option is more useful. So when I look at these expressions, and everything that you're seeing right now comes up in calculus. So we really want to get that out of the way. So this is actually, if you think about it, I could do this two ways. I could say that is, you know what, let's use exponential rules. 4 is 2 squared. And you multiply the powers. 2 times 2/3 is 3, and that's an 8. Or, you could say That's the square root of 4 cubed. That turns out to be very useful. Square root of 4 is 2, and 2 cubed is 8. Either or, you don't have to do both, of course. You can do that on every problem. I'm going to stick with this. The reason I prefer that, it's important for you to see, especially if there are variables. Okay, I'll get it to move. It's important for you to see that this is a square root. So I would look at this again. I'll do it both ways. You could say that is 5 squared raised to the 3 halves. Multiply the powers, and that's 5 cubed, 125. You could do that. I prefer you do square root of 25, but again, you don't have to do that. And if I get to the last problem, I suggest you get rid of negative powers. That's 1 over 16, the square root cubed. That is 1 over square root of 16 is 4 cubed, and 4 cubed is 64. Now, if I want to simplify these expressions, this is x. When you multiply terms with the same base, you add the powers. So this problem is a matter of how quickly can you add those fractions. LCD is at 12. Multiply by 4 top and bottom, that's 8. Multiply by 6 top and bottom, that's 6. Multiply by 3 top and bottom, there it is. And that is 14. 14 minus 3 is 11 over 12. That's a fine answer. The rule is, if you start the problem with fractional powers, you could leave the answer with fractional powers, but I'm going to write an extra step. You could say, if you wish, you don't have to. You could say, this is the 12th root of x to the 11. But this is a fine answer. Here, the same rule applies. You look at this, say, wait a minute. Couple of choices really you could do. One, you could say, I'm going to distribute that in. You could say that is 2 squared, right? So when you distribute the 3 halves, x to the negative 3 halves, y, 1/3 times negative 3 halves is 1/2. The denominator is x to the 3 halves. Again, you have multiple options. And here you could say, this is, the 2's cancel out when you multiply those, that's 8. I could move this down, right? And say, and subtract those, move this down, or subtract, either or. So I could say that's x to the 3 halves. When this moves down, that becomes positive 3 halves. Y to the 3 halves. When this moves down, becomes y to the negative 1/2. And you could say that's 8 over. When you multiply those, you add the powers. That's x to the 6 halves is 3. And when you multiply those, you add the powers. 3 halves minus 1/2 is 2 halves, which is 1. Of course, there are many ways you could do this problem. You could say, forget that. What I'm going to do, I'm going to combine those first and write it all to the 3 halves. You could do that. And then you could simplify the inside first. 4. You move this down because that's larger. That becomes x to the 1 times x to the 1, which is x squared. And you move this down because that's larger. That becomes y times y to the negative 1/2. So y, 1 minus 1/3 is 2/3. And now you could say this is the square root of 4 cubed, that's an 8. Multiply those, that's x. Multiply those, that's y. X cubed, I'm sorry. The 2's cancel out, and you're left with x cubed. So how do you do this? It's up to you. It doesn't really matter. I need to be able to simplify those. So expressions like those occur in calculus. I need to be able to combine like terms because I need to figure out where does this equal 0 and where is it undefined. So simplifying is a must. The LCD is 2x to the 1/2. This is over 1. You multiply by 2x to the 1/2 top and bottom. You will have a 1 plus x. When you multiply those, you'll get a 2. x to the 1/2 times x to the 1/2 is x to the 2/2, which is 1, and that turns out to be 2 plus 1, 3x plus 1 divided by twice radical x, or x to the 1/2. Now if I say where's this undefined, you'll say when the denominator equals 0 at 0. Where does this equal 0? When the top equals 0 at negative 1/3. So this is a must. Looking at this problem, I would need to factor. I know you're not used to factoring negative powers, but if I told you we have a to the 1 plus a to the 6, and I say factor, don't you take the term with the smallest power? You take a to the 1, and then you take this divided by this, that gives you a 1, and you take a to the 6 divided by a to the 1, and you subtract 6 minus 1, which is the 5. Let me apply the same analogy on this problem. If I look at which is smaller of these powers because they repeat, it's really negative 2/3. I'm going to factor out an x plus 1 to the negative 2/3. When I take this divided by this, I subtract the powers. What is 1/3 minus a negative 2/3? That's 3/3, which is 1. And if I take this second term divided by this, I'm left with x times 1/3. So this is x plus 1 to the negative 2/3, and this is all over 3 altogether. I'm looking at 4x plus 3 over 3, the cube root of x plus 1 squared. If I was to say where does this equal 0, you'll say at negative 3/4. Where is it undefined? At negative 1. That's a must. Now, you could do this differently, and I don't mind how you do this. You could say, I'm going to write this as x plus 1 to the 1/3 plus x over 3, the square root of x plus the cube root of x plus 1 squared. The LCD is 3, the cube root of x plus 1 squared. You multiply this top and bottom by that. 3 times the cube root of x plus 1 squared. 3 times the cube root of x plus 1. Okay, I'm running out of space. I could make space. That's easy. So here I'll get 3. When you multiply the cube root, you write a single radical, and x plus 1 times x plus 1 squared is x plus 1 cubed plus x. The denominator, I don't touch anymore. The top, those undo each other. I'm left with 3 into x plus 1 plus x, which in turn turns out to be 3x plus 1 is 4x plus 3 over 3, the cube root of x plus 1 squared. There it is. Couple more of those and I'm done. If I want to combine those, the common denominator in this case is a big mess. It's a 24 cube root of x minus 2 squared cube root of 8x plus 1 squared. And this does happen in calculus. This is coming your way. What is this missing to have the whole LCD? It's missing an 8 and the cube root of 8x plus 1 squared. 8 and a cube root of 8x plus 1 squared. So that's 8. When you multiply this by this, doesn't that give you the cube root of 8x plus 1 cubed plus, this is missing the x minus 2 squared under a cube root. The x minus 2 squared under a cube root. When you multiply those, you write a single radical, and x minus 2 times x minus 2 squared is x minus 2 cubed. And do you notice what just happened? I could combine the denominator, but that doesn't get me anywhere. The top is going to be 8 into 8x plus 1 because those undo each other, plus, and those undo each other, x minus 2, and altogether I'm looking at 24 cube root of x minus 2 squared cube root of 8x plus 1 squared. And as for the top, that is 64x plus x, 65x. 8 minus 2 is a 6. If I was to say, where does this equal 0? You'll say at negative 6 over 65. Where is it undefined? At 2 and negative 1/8. I do want to point out really quick, a quick reminder of how complex fractions work. If I take a look at this fraction, if I take 1/3 plus 1 over 6 over 3/2 plus 2/3, the quickest way of solving this is to make sure that this denominator and this denominator are the same. And I'll show you why. The LCD is a 6 for the top and the bottom combined. This is missing a 2. This is missing a 3. And this is missing a 2. The reason for that is, if I track those denominators, this is going to be over 6. This is going to be, I went too high. This is going to be over 6. This will be 2 plus 1, which is 3. This will be 9 plus 4, which is 13. And wouldn't you say that's 3 over 6 multiplied by 6 over 13? Because instead of dividing, maybe I should do it in 2 steps. Divided by 13 over 6. Wouldn't that be 3 over 6 multiplied by 6 over 13? And do you see what happened? Do you see that if these are the same, eventually they always end up being on opposite sides? Instead of doing the top separate and the bottom separate, then you have to do all of these steps every time. But since I already know if this number is the same as that number, and eventually I'm going to end up having this on the opposite part of the fraction, and they're equal, they cancel each other out, then guess what? I could save myself all of this work. And I could say, you know what, from the very, very beginning, I could have really not wrote all of that stuff. Since I know the denominators are going to cancel out, all what I have to do is make sure that all of these are 6s. And since I know this is going to end up on a part of the fraction in which this is not, they're going to cancel out. So I could just read the top. 2 plus 1 is 3, and 9 plus 4 is 13, and I'm done. Similarly, if I look at this problem, this is another example. If I want to clear this fraction, and this is, again, these come up a lot more than you like. If I find the LCD for the top and the bottom combined, isn't that xy squared? What is this missing to have the whole LCD? xy, xy. This is missing an x. This is missing an xy. This is missing a y squared. My mistake. Look at that. You guys didn't say anything. This is missing a y squared. And this is missing an x. And all what I have to do in the next step is write it as a single fraction, and I'm done. This, you just ignore the denominator if they all have it. You read the top. The top reads 3y squared plus x, and 2xy plus x. You could factor that further, but that's the idea. And when I get to those problems, we have 3 more to go, 4 more to go, 5 more to go. Nice. This is a complex fraction. Find the LCD for the top and the bottom combined, and you eliminate the complex, make it a single fraction. The LCD is twice square root of x squared plus 1. So you multiply this top and bottom by that. And this is missing the whole thing. Don't forget the denominator. That's the catch. And what you do now, you simply read the top of each of those fractions. When you multiply those, the radical cancel out. Minus 2x squared, and the denominator will be 2. If you take this to the 1/2 times itself, that is x squared plus 1 to the 3/2. And that's 2x squared minus 2x squared, they cancel out, plus 2 over twice x squared plus 1 to the 3/2, and those cancel out, and you're left with 1 over x squared plus 1 to the 3/2. So these are a must. Here, the same deal. I'll write this as the square root of 9 minus x squared plus x squared over the square root of 9 minus x squared. This is called the quotient rule. Something that you do in calculus a lot more than you like. You assume those are fractions. Your goal is to make sure that all of these are the same. So you multiply this top and bottom by the square root of 9 minus x squared. And you ignore everything in yellow. A radical times itself cancels out, plus x squared. And this quantity and that quantity are the same. This is to the 1 power, this is to the 1/2. So you add 1 plus 1/2 is 3/2. Those cancel out and you're done. So this part of the simplification is a must. This problem requires factoring. Which is bigger, 4/3 or 1/3? So I'm going to factor out x squared plus 4 to the 1/3, the smaller. If I take this divided by this, wouldn't you write the base and you subtract the powers? What's 4/3 minus 1/3? 3/3. And if you take this second term divided by this, that will cancel out, and you're left with x times 4/3 times 2x. The reason they're giving you the problem that way, that's literally how you get it in calculus when you take a derivative. Now you just have to simplify. That's to the 1. And here, wouldn't you say that this would be 8x squared over 3? And wouldn't this be x squared plus 4 to the 1/3? You have a couple of options here. You could just add those. You could put the whole thing over 3. It makes no difference. You could say that's all over 3. That is 3x squared plus 12 plus 8x squared. That's fine. And then from there you would say that is really the cube root of x squared plus 4 times 11x squared plus 12 all over it. Another problem. I couldn't fit those side by side. I tried. They're too big. So here, if I want to factor, I notice an 8 and a 6. I could take a 2 out of those. X to the 1/2, x to the 3/2. The smaller is 1/2. If I take this divided by this, 6 divided by 2 is 3. The x to the 1/2 cancel out. You're left with 2x plus 8 divided by 2 is a 4. X to the 3/2 divided by x to the 1/2 is x. 3/2 minus 1/2 is 2/2. So that is twice radical x times 6x plus 9 plus 4, 2 over 2 is x. That's twice radical x times 10x plus 9. So these simplifications are a must. And the last problem, I notice there's a 6 in both. I factor that out. They both have 6x plus 1. 1/3 and 4/3. The smaller is 1/3. And they both have 4x minus 3. 3 halves and 1 half, 1 half. When I take this divided by this, the 6's cancel out. Those cancel out. When I divide those two, I'll get a 4x minus 3. 3 halves minus 1 half is 2 halves. Plus, when I take the second term divided by this, the 6's cancel out. 6x plus 1 to the 4/3 divided by 6x plus 1 to the 1/3. You subtract the powers. 4/3 minus 1/3 is 3/3, and this cancels out completely. I'm sorry. 4/3 minus 1/3 is 3/3. So my answer is 6 times the cube root of 6x. You could leave it as a fractional power, that's fine. Times the square root of 4x minus 3 times 4x minus 3 plus 6x plus 1. So that is 6, the cube root of 6x plus 1, the square root of 4x minus 3, 10x minus 2. I could factor a 2, but that's not needed. You could say factor a 2 out. That's 12 times the cube root of 6x plus 1 plus times the square root of 4x minus 3 times 5x minus 1 if you wish, but this is a fine answer. And a lengthy section. It covers an entire chapter normally in algebra, but there